This lesson is on shifting or translating and reflecting trigonometric graphs. So we've already made, we've stretched and shrunk the graphs using the amplitude and the period. So when we look at these two equations, we've already talked about when shifting it based on numbers outside of the parentheses. Okay, if we're multiplying outside of the parentheses, we talked about that. But now we're going to talk about these extra shifts here. Okay. All right. And these shifts, these shifts work just like the shifts that we did in Algebra 2. So if we're inside the parentheses, we're going to shift left and right. So a negative actually shifts to the right that many units, and a positive shifts to the left that many units. And then outside of the parentheses is going to be shift up or down. So the first thing I'm going to do in any of these problems is find the amplitude A, find the period, which is 2 pi over b still, but now we're going to add a horizontal shift H, okay, and again opposite signs left or right, and a vertical shift up or down of K. All right, step 2 is we're going to draw a new, I like to draw a horizontal line that's kind of our new midline. So with the sine graphs, we used to, hit 0, come from 0 and everything, but now we're going to come from a new midline. All right, so we're going to call that the midline. Then we're going to find, we're only going to do one period of each thing, and we're going to find 5 key points by translating the graph horizontally by h units and vertically by k units. And then we're going to draw the graph through those points vertically. And as another note, if you write this, if we have a negative A equals a reflected or flipped graph. Okay, so let's do some examples. Let's shift some graphs. So we already stretched and shrunk and did that, but now we're going to talk about the shifting of the graphs. All right, so example number 1, and again, we're only going to do one period of these instead of, I think before we were doing 2, but we'll just do 1. 3 sine 2x plus 1. All right, so on the side here, let's talk about our A, or our amplitude is 3. Okay, so that's our amplitude. All right, our period is going to be 2 pi over b, which is b is 2. So our period is going to be pi. All right. Let's see if there's a horizontal shift. A horizontal shift would be inside parentheses, and there's no parentheses, so we're going to say, all right, there's no horizontal shift. Vertical shift, we're going to have k equals 1, so we're going to go up 1 for that. So our new midline, based on that, is not going to be equals 0 anymore. It's going to be y equals 1. All right, so let's graph that. Then again, we're only going to graph one period, and we'll kind of talk about how we shift it. All right, so I'm just going to do a positive quadrant, all right, or where x is positive. All right, at 1, that's going to be my new midline, so I'm going to put a midline there. And my amplitude's 3, so from there, I know I'm going to go up 3. So I'm going to do 3 up to 4, and then down 3. All right, now we got to figure out our x coordinates, and our period is pi, and I'm going to go half is pi halves. Half of that is pi fourths. So that makes this pi fourths, 2 pi fourths, 3 pi fourths. And then we're going to do the same basic shape for a sine that we always have done. Okay, start at 0, but now we're starting the midline. Go up, back down, down, and then up. So let me show you what I mean. Start at 0, which is actually 1 at this time, up to 3, back down to here, then down 3 here, and then back up to the midline. So the basic shape doesn't change. We're just shifting up or shifting left or changing our period. All right. So again, once you get all the information like we have on the right, graphing it becomes pretty straightforward. All right, example number 2. Y equals -4 cosine 2x plus 3. Again, we're not dealing with any parentheses, so we know we're not going to have a horizontal shift. All right, but we will have vertical because of that plus 3 hanging out there. Okay, so amplitude is 4. And it's a -4, so we're going to reflect the graph. So the graph is reflected. There's no horizontal shift because there's no number inside of parentheses. Let's see, we have a vertical shift of 4. All right, so our new midline is 4. Wrong. My midline is not 4. That's the amplitude. Shoot. Our shift is 3. Why is it erasing? Oh, there we go. All right. So plus 3. Our vertical shift is up 3. So K equals 3. Up 3. So our midline is Y equals 3. Oh, our period. We forgot about that. All right. The period is 2 pi over 2, which again is pi. Oh, that makes life a little bit easier because we already know those points. All right. We're going to do one positive period. All right. So we know we're going to shift up 3. All right. So 1, 2, 3. So that's my new midline. And I need to be 4 above that and 4 below it for my amplitude. So 1, 2, 3, 4. 1, 2, 3, 4. All right, our period is pi. So we know this could be pi halves. And just like we said before, pi fourths, 3 pi fourths. All right, so now we're going to graph our points. Now remember, we're reflected. So instead of starting above the midline like cosine normally does, so cosine normally starts up and comes down, we're actually going to start below. All right, so we're actually going to start at 0, 4 down. So 1, 2, 3, 4. Then we go to the midline, and then we go to the top, and then we come back to the midline, and then we go down to the bottom. So there's the 1 period of cosine. Again, it's up instead of the W shape. Okay, it's like an upside down W, which would be an M, right? All right, so again, I'm starting down because of the reflection. So why am I want to start here because of the reflection? Here, because of reflection. All right, let's do 4 more examples. Let's go for it. Woohoo! All right, next example. Let's now shift a tangent function. And remember, that period is not going to be 2 pi over b. It's going to be pi over b. So keep that in mind. All right, so let's do example 3. Y equals 2 tangent. And we're going to have a shift on the inside. Whoops. Pi fourths. Stick to my example I have in front of me or I'll get really confused. Okay. So this has, let's see, we don't talk about an amplitude. We talk about the y coordinate at halfway. At halfway is going to be same as what we used to call the amplitude. So that's going to be at 2. The period is going to be pi over b, which equals pi over, we assume there's a 1 there, so it's pi. It's going to have a horizontal shift to the left pi halves. So h equals negative pi halves. Remember, opposite signs when I'm in the parentheses. So to the left, to the left, to the left. There's no number being added outside the parentheses, so no vertical shift. On our vertical asymptotes, all right, we're going to be why can I never spell asymptotes? Dang. Asymptotes are, remember, at pi halves 2b, so it's going to be pi over 2 times 1, which is going to be pi halves, but we have to shift it by negative pi fourths. So don't forget that. So we need to shift everything over by pi fourths. So here we go. And I think since we're shifting negative, our positive is going to shift over there. So let's put our thinking hats on. Thinking hats. So a period for tangent normally looks, well, you know what? I'm going to draw, I don't know if you need to do this, but I'm going to draw that parent function, and we'll talk about how it shifts below here. So the parent function is pi halves to negative pi halves, and the midline was at pi fourths and negative pi fourths, and it would be at 0, my midline, and then asymptote, asymptote, and here. You don't need to draw this, but I just want you to see kind of like what I'm doing here. I'm going to shift all those numbers by subtracting all by pi fourths. Okay, because I'm shifting over to left pi fourths. So if I shift the whole graph over, instead of my asymptote being at pi halves, it's going to be at pi fourths. I subtracted pi fourths from pi halves. Okay. My midpoint is now going to be at 0, because, all right, so, and it's going to be up at, what did we say it was? 2. So we're going to go up 2, down 2. Why did oops, I didn't mean to put that dot there. Ah! All right, let's draw that back over. Ooh. Okay. This is horrible looking. All right, so my midpoint is going to be at 0 because I subtract pi fourths by 0. All right, my 0 point's now going to be at negative pi fourths because I got to shift it. And then this will be another negative pi fourths minus pi fourths is negative pi halves, and then we know that the next asymptote will be at negative 3 pi fourths, because I just take all these numbers at the bottom graph and subtract them by pi fourths. So then we'll be here, asymptote, there's my graph. I don't like that graph. Try that again. There. All right, so again, you didn't have to draw the bottom graph, but I just want you to kind of see where it was shifting from and what I was thinking in my brains. All right, next example, let's do another cosine graph. So let's see, y equals 2 cosine x minus pi thirds. Okay, let's write down all the information we can. The amplitude is 2. The period is going to be 2 pi over 1, which is 2 pi. There's no vertical shift because there's nothing on the outside. Oh, I skipped horizontal. That's all right. We'll come to it right now. All right, horizontal is going to be h equals positive. So we're going to shift to the right because remember opposite signs. All right, so let's think about the original period and then we're going to add the shift to that. All right, so I'm going to write that over here and I think it probably would help to write it. All right, so normally for cosine we would start at 0, then we would go since the period is 2 pi, it'd be here, and then halfway would be pi. So this would be pi halves, and this would be 3 pi halves. But we need to add, we're going to shift all these up by pi thirds. So my real one now, let's see, so new, I got to add. So my new one is going to be at pi thirds. Okay, so 3/6 plus 2/6 is 5/6. You can always do in the calculator. 3/3 plus, that'd be 4/3. Okay, all right, hold on. This would be 9/6 plus 2/6 would be 11/6. And then 6/3 plus 1/3 would be 7. All right. God dang it. So let's put that over here. Let's go ahead and graph it. 1 period. We don't have a midline. We're just going to use the regular midline. We're not reflected. We have an amplitude of 2. Down 2. All right. And we're going to be at 7 pi 6. Halfway of that is 4 pi thirds. We're going to start at pi thirds. Oh, shoot. That's not right. Hold on. Nope, because that's not halfway. Hold on. Let's try that again. Pew, pew, 1, 2, 3, 4, 5. And we'll just copy that over. Pi thirds, 5 pi 6, 4 pi thirds, 11 pi 6, 7 pi 6. We're going to start up because we're not reflected. Up 2 to 0, 2, and back up. And there's that W shape we're looking for. All right. All right, 2 more examples. All right, example number 5. Y equals, reflected graph. What? I put that parenthesis in the wrong place. Give me a hot second. All right, so there we go. That's what I want it to look like. Let me fix that on my sheet of paper I'm looking at. All right, fixed on the sheet of paper I'm looking at. All right, amplitude is 3. I am reflected. Period 2 pi over 2. So that is going to be a period of pi. There is no vertical shift. There is a horizontal shift of negative pi fourths, so that's to the left. All right, so let's do that. Let's draw that out again. All right, so if our period was pi halves, 0, pi fourths, 3 pi fourths. And now we're going to subtract pi fourths from all these. That is the worst looking pi fourths I've ever seen. Here we go. All right, so our new ones are going to be 1, 2, 3, 4, 5, negative pi fourths, 0, pi fourths, 2 pi fourths, which is pi halves, and then 3 pi fourths. All right, so our original, we subtract the shift, and then there's our new. All right, so let's graph that. And we're reflected, so we're going to move down first instead of up first. We're going to start at negative pi fourths, and then we're going to go to 0, and then we're going to go to pi fourths, and then pi halves, and we're going to end at 3 pi fourths. And we're going to go up 3, we're going to go down 3. All right, so start here. I want to start there in red. And then we're going to move down because we're reflected. There we go. So there's our reflected sine graph. Reflected. Wait, hold on. Oh no, that's right. It took me a second. All right. All right, one more example. All right, so the final example is y equals 2 minus tangent x. And what I like to do for this one, because it's not in the right form, is I like to rewrite this as y equals negative tan x plus 2. I just shifted, that way the midline shifted, it kind of looks like what we've been doing. All right, so let's see, let's do y coordinate at midpoint would be 1, okay, all right. Oh, it's reflected because it's a negative 1. There's no parentheses, so we're talking no vertical shift, or no horizontal shift. Vertical shift. It's going to be k equals 2. So if we come back up to here, we're going to do 1 plus 2, which is 3. And then it would have been at negative 1. So negative 1 plus 2 would be at 1. So that's where we're really going to be at. And vertical asymptotes. Are going to be at pi 2 times 1, which is pi halves. So just like the parent graph. So let's graph this. All right, and we had no horizontal shift, so we just graph it right at 0, 0. All right, and midway point pi halves, midway point pi negative pi halves. Our new midline is going to be at, we're up 2, 1, 2, and then we're going to go up 1 and down 1. Doop, 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 doop. And because we're reflected, we're going to actually start instead of being shaped, we're going to come down and then, so let's see. The 0 shifted up. My midpoint, I'm going to come from this direction now and then here because I went up, down. And there's my graph. All right, so that's shifting and reflecting graphs. Remember, if you have questions, please ask me.